available. Huh? Hello, I'm Goran Mekic or Meka. You're uh, watching Tilda podcast on a project called CBSDng. It's based on CBSD and um, up to a degree, it's um extension of the CBSD. So these three repositories is what are we going to uh, observe today mostly, and topics are wild. So stay tuned, um, and I hope you will find this way of presenting something you can follow. Oh yeah, let me see. So all right, now I can read this. Right. So there are three repositories that are reggae services, and this project uses three services. Where this demon has two services, and it's probably going to be renamed, but not yet. So, um, let me just show you how the main program looks like. And okay, so this is basically it with some folding enabled. This is where the options are being parsed, and this is um, where the hmm, maybe I need this. Right. So if you give it to dash d, is gonna uh, set this variable d, which is boolean and false by default, go to true. And if that happens, then it's going to go to background, and the default logger is going to be set to syslog. I'm gonna show you in a minute what that means. Or if this program is not to go to background or demonize, then use the uh, standard output, which is colorized also. So use that to uh, log whatever you need to log. And how it looks, this is, well, something I obviously don't need. Uh, so it's just an example. This is how you get, because this SPD log, I suppose it's speedy log. Uh, it's a C++ library that, well, logs. And there can be multiple loggers. So, and only one with same name. So either you're going to demonize, go to background, and then you need to check your var log messages, or you're going to get everything on your console and some stuff is going to be colorized. Uh, by the way, it's cool that it supports lib format, libfmt. It You can format strings really nicely, but We're gonna talk about the logging some other time. It's just this is the way to make your logger make the rest of the code have no idea where they're logging stuff while still um, doing the right thing. Uh, oh yeah, this can be anywhere in the code. Actually, it doesn't have to be in this file, and you only need this include. So the main include, and you basically get the default logger, and you tell it either warning or error, or depending on what happened, you're spewing out messages there. I needed that because I had an error a bug that was only visible if you're demonizing, and by default, these two zeros actually mean that uh, the standard input and output is going to be closed or redirected to dev null. So nothing is going to be emitted. And you need a logger for that. So I need something to uh, tell me what's going on. And the log was the easiest solution. So this is the cute little uh, library that r- really makes logging easy and telling yourself as a programmer what your program is doing. I really like it. Anyway, uh, let's see what's going on in the main. So this is actually where the stuff actually happens in this program. So what does that mean is we're going to wait in the main thread for the client to connect. Now, client is either shell or a web backend. Uh, so either there's going to be some more C++ or some more Python. And if there's an error, well, huh, what you gonna do? We just continue with this loop and notify the user. The, well, yeah, I still didn't get the time to log everything properly, so this is not going to work when it's demonized, of course. But it's either some error, and we say, okay, just ignore it, wait for the next client, and do something with it, or the client is not -1; it's some meaningful number, and we assign it asynchronous worker to does this allocating, and um, it's going to signal itself to be removed. So what I mean is that give me just a sec. We're going to create a thread that uses this function um, to to do whatever it needs to do, and it's going to spawn a new thread for every client that connects. The process is pretty simple. It's going to receive a message from the connected client. It's going to execute that message. It's going to do something here. I'm going to go back to that a little bit later today. Uh, but basically, it notifies someone, hey, how about you clean up after me? Uh, it's this function, but let's take a look at the execute first. That's where the fun stuff is. And the fun stuff, I promised that there's going to be pseudo terminals, and that's what this function does, among other stuff. It's fork, but fork function is something that's going to give you two processes. One is the parent and one is the child, and it's all cool. You can run it like that, and when this uh, function is called, let's just imagine it says fork here, not fork pty. When this function is called, the speed is going to be set, and it's either an error or there are two processes now with the same code that are running. So one has PID 0. I mean, the PID variable is set to 0 is if we're inside a child from that fork. Otherwise, that it has some meaningful process ID. I mean, the process ID that is stored in this variable is from the child. So the parent knows the child's process ID, and that's useful. But okay, let's see what's going on. So when this command is as a message, when it is received, then it's either beehive or jail. So this prefix is either J or B, and we compose a message here. Uh, we have arguments to the CBSD command that are going to be executed, and we are pushing them back token by token. And then when they're all in this vector, or it's like an array, right? Uh, we say, okay, execute that, whatever we parsed. This is not some parsing that you can say, okay, it's going to be good. I mean, nothing is going to explode. Uh, so I didn't pay attention to the strings that I'm parsing. They can be malicious at this point. But on the other hand, I was having a problem with protocol itself, so I didn't want to parse in more detail and make it more complicated. Anyway, this is all it does. It executes, and that's it. This, um, well, that's not it actually. This function is going to run our CBSD command, and then, okay, let's just ignore all that. Then the parent is going to wait for a child to die. Uh, IT people sound terrible. Uh, So it's going to wait for child to finish whatever it has, child being CBSD command, for example, JLS to list your jails. And in the meantime, it needs to capture the output uh, from child and transmit it to the client. And in the same time, maybe it's interactive command, so it needs to capture the input from the client and push it towards the child. And that's what's actually going on here that I folded. KQ is really, really helping. I can't overstate how much I like that API. It's really, really simple and powerful. So what's going on here is that we're telling it, okay, what I want to be awakened about is either there's something from the child process or the client typed in something and we're sending it. Right. The client raw is this is actually file descriptor, and child here is already a child descriptor. It's this PID up here. No, wait, what am I talking about? Um, yeah, this child. So we know it's file descriptor, and we're waiting for event, and then event happens. If there's an error, okay, just finish because you're in a thread. Just finish, and that's it. Uh, I mean, it's going to go to the out of while, and it's going to wait for the child, and then it's going to finish. But there are two events here that we're interested in. So there are two um, branches, two different scenarios that this code handles. One is the child has something on its output and we are reading it. So allocate the buffer and put it into message and then transmit the message to the client. Or there's something from the client, read it, and then write it to the child. Um, Now this client here, for example, is ultimately it's Unix domain socket. That's how it's implemented. And what's going on here is that um, we could use something else. What I'm trying to remember, I had to write three functions which are read, write, and write. And you can basically use those uh, in the same way the operator uses them, but I think this way it's even obvious where the direction of the data flow. I don't know. I like operators. Uh, anyway, this is always happening in a thread. So every new, whenever you spawn a command through shell or backend or maybe in the future something else connects, one thread is going to be spawned and the CBSD command executed, basically. Maybe there are going to be commands that are do not require CBSD to be ran, like some information or something. But this is the how the engine works. This is what we are doing here. And last uh, last podcast had a problem. Let me see just if it's here. Right. Um, I think this is it's the easiest to understand in these three commands. What's going on with the protocol? As a matter of fact, let me show you in the browser. So what we have here is a protocol that is being exchanged through that Unix socket. And you can see that when you send ls, what actually is being sent through the wire, so to speak, is ID, type, and size, which are unsigned integers. I think, yeah, they are unsigned 32-bit integers, and they're this is what is uh, transmit it through the wire. There are no spaces here. It's just easier to read if there for humans if there are spaces. So there are no spaces here, so that there are 32 bits for this one, then this one, then this one, and then this is basically stream of bytes, which string is actually. Uh, and we need to read that somehow. So it's in chunks of 3 times 32 bits or 4 bytes, right? We do it 3 times, then we this size is going to tell us how big this is and how much till the end of the message. And when we when we take a look, we are going to use this 3 times, then this one once, and no wonder that's exactly what's going on in operators, right? Read it, or when it's transmitting, right? Write it 3 times as a number, and then write the payload as a string. The read is a bit more, I think, complicated because is yeah, setting all kinds of errors if there's something happened, and it knows how to return -1 is a message that has error as in its payload. So when some function up there knows what happened when we transmit it, right? Either shell or web or whatever. And this is the core of executing CBSD commands. This is how it happens. Oh yeah, I promised you I'm gonna show you cleans up after itself. Basically, it boils down to this and a little quirky thing called you cannot remove the branch you're sitting on. So this is what should happen. You should execute and then you should signal someone uh, that it's over. Basically, you're trying to do which is illegal, of course, but this is why we are doing it because we cannot do it like this, and we really, really need it because everything is over, execute, finished, and it's over. So, because we cannot do that, we have to. Uh, Let me actually show you like this. We have a list of asynchronous workers that finished. It's pointers to this basically, and we have one thread that is just waiting for this mutex to unlock, or actually, this is how condition variables work in C++. So it's waiting for this finished list not to be empty. And then when it's not, it takes the first one, removes it from the finished, uh, and it says if the worker is not null, uh, just remove it. Right? We need to delete this, and it's basically what it does. Why we can call it here? I cannot call it here because I'm cheating. because this is static and execute is not, and process is not. Uh, so the static changes things because uh, it's not part of an object we're trying to delete, so we can do it. We're not trying to shoot ourselves in the foot. And if I say, okay, the quit, which is, I think, also static, yeah. Uh, if I need to quit and there's nobody else to process, just return. That's it. Then we're true, and that's what this remove finished does. That's basically all. Um, I think I implemented this a while back, so I gotta refresh my memory. But in order for this, oh my god, you're watching the browser. Damn it. Damn it. Okay, I'll have to edit this. Sorry. Um, so the process is simple. Basically, it needs to receive the message, executes it, and um, and we want to remove ourselves. Not that we can, because this is part of an object, so we cannot delete ourselves. But because remove finished is static, it's not part of an object we're trying to delete. We can use a condition variable to wait until this finished list becomes populated, because somebody finished executing and pushed back. Uh, and we're going to receive that worker, remove it from the list, and see if that worker is a null pointer or not, and then delete it. If we need to quit, we're not going to do that until we empty the list of uh, pointers to asynchronous workers that finished. Uh, so this is gonna, as this is a loop, we are going to drain this finished, and then when it's empty and quit, we're going to return, because the whole program needs to end, and all its threads need to end. That's how we end this one. And sometimes the worker in the finished list is going to be null pointer. That's, I think, when you need to notify this remove finished, because this will not uh, this will hang if the this list is empty. So when you want to kill it, want this remove finished to return, you put an empty the null pointer into this list, and then um, it's going to wake up. Basically, that's what's going on. So there is one thread that is cleaning up after other threads when they say they're finished, and more lines than that. Okay, so uh, there is one problem with this. It's okay, it works, as long as your command doesn't need any input from or standard input to be precise. That means that the and just hide the irrelevant parts. Right. So that means that you need a pseudo terminal device, and it is PTY. So not only does this fork, as I explained, but it also gives makes pseudo terminal available to the child. So this execution of the command here can use standard input and output, and still, although the daemon itself doesn't have that, it's uh, it's not enabled for it. So uh, this is what makes forking of commands that read input possible, and we're going to um, use that in just find it here. Whatever we receive from client, write it to the child, and that's why it even works, because we have a terminal allocated for us, and that's it. um yeah, there was an error last week with interactive commands. I actually have no idea what the error was, because I redesigned the protocol. uh, I used uh, strings to communicate uh, back and forth from the client to the daemon, and back, what needs to be done and what's the output, and so on. But then um, I done it intentionally because I didn't know what the protocol is going to be, and I didn't want to parse it much. So I said, okay, for now the strings are cool, but then if I put 32 bits into one variable, it's going to be integer right away, and there's no parsing. So there are some things that just the choice of variables can be enough, can do enough work and parsing for you. So cool. Yeah, once you know what you want, what you're doing. So let's see what we have here. I'm not gonna go to background yet. And this were actually no, wait. We don't need this, and we don't need this. All right. So one more time, ls works, but it just worked even before, so nothing new here. But this works now. It really behaves like a shell, and whatever I um, type is going to be transferred to the daemon. So, for example, if I type Control D, that's not the command for the shell for this zero. It's going to be transferred to the daemon and then feed it to the CBSD command, which actually executes all this and returns the output back. So that's why log out works. And one little thing that is really cool, even this works. All right. Now, these are the little, how to say, treats, because I didn't expect any tweet to work. I hardly communicated characters there and back. So, yeah, it was interesting. Uh, but yeah, this works. Tab also works, and it's not very intuitive. So yeah, I press Control C right now. No, it doesn't work. Right, it doesn't want to die. Okay, so if I type yes and Control C, then yes is going to die, not my shell, not CBSD command, right? Not all those programs in the chain are not going to die, but the yes as a shell command will be sent a signal. And this is these are the two how to say ways of interprocess communication. One is through I just showed you how the input and output are redirected in the parent, and the other one is through this Unix socket between the let's say unrelated process, meaning our daemon didn't fork it; it just came in. We ran the shell command or we executed something in the backend, right? And in that sense, it's unrelated to daemon, and that's how. Well, there's two ways how the processes can communicate back and forth. By the way, I mentioned that there's something special about the terminal, and there is in the client basically everything's in reverse when daemon sends client receives. So uh, there's basically nothing new there, and it also uses KQ to wait for either user input from the keyboard or message from the daemon from CBSD. And only interesting thing is this, um, which says whatever is in here, invert it, and then set it here, which basically says turn off these options, which are uh, all of them together. Tell the terminal, please don't do absolutely no processing, nothing. Uh, don't echo like these few or don't echo anything. Don't do any processing. Don't Control C signal. Don't send it, and bunch of stuff. Just turn it off. The CBSD command that is running inside the daemon is going to actually do that, and you don't need to do anything. Just run command uh, in a terminal, or run me in a terminal that is as dumb as possible. And these are two ways how processes can communicate together, and that's how this well ls or login command work. So okay, let's go back to web. Okay, there is something I call designer. I'm an author of this software. Actually, there is. Let's start from scratch. Sorry. Uh, there is Freenit framework, and one of the components of that framework is a designer. Designer is something that you can drag and drop. Uh, this is the URL, but it should be in a description of the video. Uh, and you can basically drag and drop stuff and do design like that. Okay, so I'm not gonna design a whole page. I'm just gonna give you an idea what I want to do and how this is going to end up being a design. So I usually have an up bar, and what I want is this div that is going to have style that has, let's say, the padding is 20 pixels in the numbers. So this has some volume now, or surface. Yeah, surface. Um, and I'm going to say that it's display it should be as grid, and then the grid template rows, I think it's repeat. Uh, what we're making is, yeah, I should tell you. What we're making is a page for plans that lists all our plans. Uh, Plans are uh, template of your instances, uh, but I cannot call it template because it's a too generic term, and I had to come up with something different. So what I'm creating here is a grid inside this div that is going to represent my plans as boxes I can click on. So let's say I want 6 by I don't know what uh, grid. I just made that up. And I'm going to actually let me increase this a little bit. And then if I increased it, let's say I need 4. Now if I put, let's say, div again, and I say, okay, but you need to have a certain style, and that style is going to be with the background color that is, I don't know, green, and you're going to have height that is, let's say, 30 pixels, and now we have this. Doesn't look like a plan to me, but now we have 2 of them, and we say gray. All right. Uh, I think I didn't set this right. So CSS grid example. Of course, I have no idea. What I actually don't know is what is a row and what is a column. So I'm pretty much doing this every time. No. Okay, I don't want an example. Oh, okay. Right. Now it looks like something. And I probably want grid gap. Is it grid gap? I don't know. But wow, it is. Okay. So now I paste this one and I paste this one. So what is grid does, it lets you just pile up your elements and it's going to put them into a grid. And let's say there's one extra. Like these are the plans. Doesn't look like it, really. Now it can say okay, memory, uh, mem 1G, right? And you can basically design your page through this program. Now, why would you do that? Is the there are few features that I missed in other programs, and that's the reason I created this application. One is, well, you can save it, but a lot of other applications have save. But export does it exports the code into the React, so you can just import it into your project, and then it's going to be on some URL where you register it. Um, the idea behind this tool is that uh, one page shouldn't be made from scratch twice, once during the design itself and second time during the coding while the front end developer is working on the code that looks like design. So this is actually going to look, I mean, it's a new project, 4 weeks old. Uh, Not so much in real time, but up until now, I got only 4 weeks to dedicate to this project. So um, there are bugs, and when you load what's exported here as a page.js, you get uh, React code. For a complete tutorial on how the designer works, I recorded a video on that few days ago. So go check out tilda.com. No, tilda.center/YouTube. And you're going to be on our channel, and there is a video on designer. Now, you basically get the idea how this is going to work. We're going to take this design and we're going to export it, and then give me just a sec. Then we are going to put it into project. CBSDng, we need services and front end. Okay, so, oh, no, I didn't want that. Give me just a sec, something died. Alright, now let's see what's going on with that page. Hooray. Okay, so now this is what it saved. And we kind of see familiar design of the divs, and one of them has some content. So I obviously need to work more on the design, and once I do, I'm gonna show you how it looks like. But you can see that the idea is to get the code out of the designer, not the picture. And I'm not gonna show you the rest of the front end now. I just scratched the surface intentionally, so you can see that I'm trying to automate everything I can possibly touch. Um, what I want to do is, last time there was an error, and I want to show you what it is. All right, so this is actually old code, and this doesn't work because I need this, and that's all that was missing in last week's episode. What was going on is I got an error about name being a type, which was true because it was without this. Name and memory are classes. And like this, they're objects which are instances of the fields. Name is instance of text field and memory is integer field. Now, I wanted to leave this as an error to demonstrate what was going on, but I want you to see one more thing, and that is only ID was registered as a field, and ID is always registered as a field in SQL with PV. Uh, it's the automatically added field, but there are no name and memory mentioned here, and we should have something like this. Wait, memory. All right. So these little nasty bugs, or um, well, nasty. It's not a lot of characters, so visually it's small. Uh, and to be honest, that's why I hate DNS. The dot, which is the smallest glyph ever, is so important. It's the most important character for DNS. So it's not nice to work with. Anyway, the visually small errors uh, are, well, because of the visual component, they're hard to track, they're hard to find. And yeah, that's why it takes so much. And but I understand what happens now. If I get error that some field is a type, I'm gonna know what it means. That this definitely is a rough teacher. Errors always are. And this is basically uh, what should have happened uh, last week, and what I was working on with interactive commands and protocol. Uh, I was working on implementing the core stuff first, which is C++, and as you can see, the Python didn't get much love. Uh, but yeah, I I think I even can't show you the. Yeah. Uh, I left when I found this error. I left it as is. I said, okay, I'm gonna fix it on the stream. But now the database also has the same messed up schema, and I can show you quickly that this works because I'm already talking for almost an hour, and I think it's enough. So thank you for watching. I want to especially thank the NGI Pointer for sponsoring the project, and I want to thank the CBSD community, especially Oleg, for uh, developing, and maintaining such wonderful software, uh, which is easy to be built upon. Uh, and thank you for being patient up until now. So, see you next week, and I hope that we're going to move towards the web more, so we can do some control from the web and from the shell uh, on the jails and virtual machines. Bye bye.